Background: circa 2100 to 2050 Ma. The stage is set. The core of what will become North America, the Superior Craton, an ancient continental shield, already exists. To its south and west, several other independent crustal blocks, microcontinents and island arcs, are moving independently in an ancient ocean. These include the Wyoming Craton, the Herne Craton, and the Slave Craton in modern-day northern Canada. 2.05 to 2.0 GA billion years ago, early Orosirian. Continental crust growth. Large amounts of new continental crust were forming, much of it through accretion of island arcs and protocontinents onto the growing North American Craton, Laurentia. Parts of what are now the Lake Superior region, the Black Hills of South Dakota, and the southwestern U.S. were being welded onto the Craton. Circa 2050 to 2000 Ma. Subduction zones are active around the margins of the growing continent. The Taltson-Thillon orogeny begins in the northwest, modern-day Arctic Canada, as the Slave Craton collides with the Ray Craton. 2050 to 2000 Ma. Event: onset of Orosirian, post-Great Oxidation event recovery. Description: following the Rhyatian period's Great Oxidation event, 2300–2100 Ma, the atmosphere and ocean stabilized with low oxygen levels. Subduction zones began forming globally, initiating arc magmatism. In Laurentia, early rifting and passive margin development occurred along the Superior Craton's southern edge, leading to shallow marine sedimentation. Modern U.S. region affected. Southern Superior Craton margin, Proto-Midwest, parts of MN, WI, MI. Key evidence/processes. Sedimentary basins with quartzites and carbonates. Early carbon isotope excursions indicating microbial activity, e.g., cyanobacteria blooms. No major U.S.-specific orogenes yet. 2.02 GA. Sudbury impact, Ontario, just north of U.S. One of the largest asteroid impacts in Earth history. Created the Sudbury Basin, 250 km wide, ejecta from which is found in what is now the Lake Superior region of the U.S. Shocked minerals and ejecta blankets are preserved in Michigan and Minnesota, marking one of the earliest globally recognized impact layers. Circa 2000 to 1950 Ma. To the south of the Superior Craton, a major ocean basin begins to close. An island arc system, known as the Pinocchian terrain, collides with the southern margin of the Superior Craton. This Pinocchian orogeny, which peaked slightly earlier but had major Orosirian-aged phases, creates massive mountain belts in the region that is now Minnesota, Wisconsin, Michigan, and parts of Ontario. This event is a precursor to the main continental collisions. 2000 to 1900 Ma. Event: early Trans-Hudson subduction and arc formation. Description: subduction of oceanic crust beneath the Wyoming and Superior Cratons began, forming magmatic arcs and backarc basins. Juvenile crust, newly formed from mantle melting, accreted, trapping microcontinents like the Sass Craton. This set the stage for continental collision. Modern U.S. region affected. Central/Western Interior, Proto-Dakotas, WY, MT, NE, extends from Canadian Shield southward. Key evidence/processes. Calc-alkaline volcanics and plutons, geophysical evidence of buried sutures. Deformation created fold-thrust belts now subsurface under the Great Plains. Middle Orosirian, 1950 to 1850 Ma. The main event, the Trans-Hudson orogeny. This is the most significant geological event to affect the future U.S. during the Orosirian. Circa 1920 to 1880 Ma. The Trans-Hudson orogeny reaches its climax. This was a massive mountain-building event comparable to the formation of the Himalayas. The Wyoming Craton, future base of the western U.S., smashes into the combined Superior/Herne Cratons from the south. Simultaneously, island arcs and other continental fragments are squeezed and sutured between them. The core of this colossal, Himalayan-scale mountain range, the Trans-Hudson orogeny, runs through what is now central Canada, but its effects extend south into the northern United States. Geographic legacy in the U.S. The rocks deformed and metamorphosed during this orogeny formed the deep basement bedrock beneath the Dakotas, Montana, Wyoming, and northern Colorado. These are the roots of the ancient mountains, exposed only in places like the Black Hills of South Dakota and the Wyoming Craton itself. In the Great Lakes region, the continued effects of the Pinocchian orogeny are felt, adding to the complex geology of Minnesota and Michigan's Upper Peninsula. Pinocchian orogeny, ca 1.9 to 1.85 Ga. Major mountain building event affecting what is now the Lake Superior region, Minnesota, Wisconsin, Michigan. Result of island arcs colliding with the southern margin of the Superior Craton. Produced thick sequences of volcanic and sedimentary rocks, many now exposed in northern Minnesota and Michigan's Upper Peninsula. Also led to the creation of banded iron formations, BIFs, that later became major iron ore deposits. 1900-1820 Ma. Event. Peak Trans-Hudson orogeny, Craton suturing. Description. Full collision between the Hern-Ray, Superior, and Wyoming Cratons sutured the core of Laurentia. Intense metamorphism, up to granulite facies, and magmatism deformed continental margin rocks. The Sass Craton was crunched in the interior. Modern U.S. region affected. Central U.S., Black Hills SD, Eastern WY, Western Dakotas, Eastern MT, Western Nebraska. Key evidence/processes. Cheyenne Belt Suture Zone, 1840, 1820 Ma granites and shear zones. Uplift formed the Black Hills, exposed core of the orogen, rising 3,000 to 4,000 feet above plains. Flattened areas contributed to later intracratonic basins. 1.9 to 1.85 Ga. Mid-Orosirian tectonics. Trans-Hudson orogeny, 1.9 to 1.8 Ga. One of Earth's largest Palaeoproterozoic orogenes, forming when the Superior Craton collided with the Hern-Ray Cratons. In the U.S., its effects are recorded in the northern Great Plains, North Dakota, South Dakota, Montana. Created massive sutures and mountain ranges comparable in scale to the modern Himalayas. Helped form much of the core of Laurentia, the stable continental core of North America. 1880-1870 Ma. Event. Initiation of Pinocchian orogeny, island arc collision. Description. The Pembine-Wausau terrain, a Paleoproterozoic island arc with tholeiitic and calc-alkaline rocks, collided with the southern margin of the Archean Superior Craton. This marked the start of compressional tectonics, with northward directed subduction ceasing and continental collision beginning. Modern U.S. region affected. Lake Superior region, MN, WI, Upper Peninsula MI. Key evidence/processes. Formation of the Inimiki Basin foreland. Thrusting and low-grade metamorphism. Associated with deposition of the 1875 Ma Biwabic Iron Formation, banded iron formations, or BFs. 1870 to 1850 Ma. Event. Main phase of Pinocchian collision, marshfield terrain accretion. Description. A microcontinent, marshfield terrain, collided with the Craton, intensifying deformation. Back arc volcanism from prior subduction filled basins with sediments. High-grade metamorphism, up to amphibolite facies, and syntectonic granitic intrusions occurred. Modern U.S. region affected. Great Lakes and Central Plains, MN, WI, MI, Northern IL/IN. Key evidence/processes. Northward thrusting folded the Marquette Range supergroup sediments. 1860 Ma plutons intruded. Created proto-mountain ranges, now eroded to form the Iron Ranges, e.g., Mesabi Range, in MN. 1850 to 1830 Ma. Event. Climax and relaxation of Pinocchian orogeny. Description. Peak collision led to widespread folding, faulting, and 50 km of crustal thickening. Post-collisional extension followed, with granite emplacement and basin inversion. The orogeny lasted 10-50 million years total. Modern U.S. region affected. Midwest, Lake Superior to WI Highlands. Key evidence/processes. high-strain zones, and gneiss domes. UPB dating of deformed zircons confirms timing. Remains visible in the Northern Highlands, WI, and Huron Mountains, MI. 1.85 to 1.80 Ga, late Orosirian. Continental stabilization. By 1.8 Ga, Laurentia, Proto-North America, was becoming a large, stable craton. Many ancient mountain belts began eroding, exposing deep crustal rocks we see today in the Black Hills, Minnesota River Valley, and northern Michigan. Late Orosirian, 1850 to 1800 Ma suturing and post-collisional activity. Circa 1850 to 1800 Ma, the main collisional phase of the Trans-Hudson orogeny winds down. The continents are now sutured together, forming a larger, more stable continental landmass called Laurentia, the ancient geological core of North America. Post-orogenic magmatism. As the tectonic forces relax, the thick, hot crust beneath the new mountain range begins to collapse and melt. Large bodies of magma intrude into the deeply buried crust. These granitic plutons cool slowly underground, forming new igneous rock. This widespread magmatic event is recorded in rocks across the northern U.S., such as the 1.8 Ga granites found in Colorado, e.g., the Colorado Front Range, and South Dakota. The famous Harney Peak granite in the Black Hills is a classic example from this time, forming right at the end of the Orosirian. Southwestern growth. Simultaneously, in the southwest, modern-day Arizona, New Mexico, and Southern California. A separate series of island arc terrains are accreting to the growing continent in events known as the Yavapai and Mazatzal erogenous. These primarily occurred after the Orosirian, in the Statherian period, but their initial stages may have begun near the very end of the Orosirian, 1820–1800 Ma. 1820 to 1800 Ma. Event. Late-stage Trans-Hudson magmatism and stabilization. Description. Post-collisional plutonism and cooling stabilized the craton. Minor extension led to rift basins. Globally, this contributed to Columbia's supercontinent assembly. In the U.S., subsidence created platforms for later sediments. Modern U.S. region affected. Western Interior, MT, WY Dakotas. Key evidence/processes. 1810 Ma A-type granites. Geophysical models show truncated southern extension by later events. Subsurface rocks underlie the Great Plains and influence Phanerozoic strata. 1800 Ma. Event. End of Orosirian. Transition to Statherian. Description. Orogenic collapse and erosion reduced mountain heights. The assembled Laurentia core entered a phase of intracratonic stability, with rifting precursors to later supercontinent cycles. Modern U.S. region affected. Widespread, Midwest to Rockies proto-region. Key evidence/processes. Erosion products formed basal Statherian unconformities. Carbon cycle stabilization with positive delta superscript 1 superscript 3c excursions in marine carbonates. Yavapai orogeny, 1.8 to 1.7 Ga, starting at end of Orosirian. Initiation of a long-lived series of orogenic events in the southwestern United States. Island arcs collided with Laurentia, adding juvenile crust to what is now Arizona, New Mexico, and Colorado. Marked the beginning of major continental expansion southwestward.